Bismillahirrahmanirrahim. Today's theorem is theorem 13.1.4. The statement of the theorem is that from point outside a line. Okay, so you have a line and a point which is outside this line means that this point won't lie on the line. The perpendicular is the shortest distance from the point to the line. So you have a line. Okay, let the line be A, B, and we have a point. Let this point be C. Okay, so from a point, we are talking about this point outside the line. Okay, this is the point which we are talking about, and this point is outside this line. It means that this point does not lie on this line AB. Okay, what are they saying? The perpendicular is the shortest distance from the point to the line. So we are talking about the distance of this point from this line. Let me draw perpendicular distance. Let this be the perpendicular distance, the distance which makes an angle of 90 degrees with AB. So we could take the distance of this point from AB in this way also. Okay, this is also a distance from the point C to the, if you follow this path, okay, this could also be the distance from C to AB. There could be many distances from C to AB, but the shortest one is the one which is the perpendicular distance, okay, which is making an angle of 90 degrees with AB. So this path, okay, this way, this is the shortest distance between C and this line AB. Okay, let this point be D. Okay, and we will have we'll do the, no, that will be in the construction. We are going to take another point on AB, okay, which is not D but some other point, and then we are going to show that if we take any other point other than D on this line, then that distance will be always greater than, for example, if I take this distance, this will be always greater than this. Okay, and this is what we have to show in this theorem. Let me read the statement again. From a point outside a line, the perpendicular, this is the perpendicular distance, is the shortest distance. Okay, it will be the shortcut from C to AB, because there would be more than one path. There are more than one path as we travel from point C to AB. We could go like this also. Simply we could go like this, or we could go from C to any other point on AB, but the shortest one is the CD path. Okay, this perpendicular path, this is what we need to show. So here what we are given is that we are given a line AB. Okay, C is a point outside this line. Okay, this is the point which they are talking about. We will be taking the distance of C from AB. Let me erase this. Okay, C, and D is a point on AB such that CD is perpendicular to AB, or we can say that CD is the perpendicular distance of C from AB. We have to show that CD is the shortest distance from the point C to the line AB. Okay, we have to show that, to prove that CD is the shortest distance of C from AB. Okay, in the construction, what we are going to do is we are going to take another point on AB. Let E be any other point other than D. Okay, this is not the D point. We will take any point E, okay, on AB. E could be any point other than D. Okay, let E be any point other than D and join C to E. Take a point E on AB other than D. Okay, and join C to E. So CE will be a distance which is not the perpendicular one. Okay, it won't be the perpendicular distance whether we take E here or to the other side of CD, but it will never be perpendicular because it is this angle will not be equal to 90. Okay, unless this point E becomes at the point D, but we have taken E as a point which is not D but some point which is other than D. Okay, we are not taking D, we are taking any point on this line which is not D. Now statement and reasons. Now this is an angle of 90 degrees. Okay, it means this angle will also be 90 degrees. Now if you look at this angle CDB, okay, this 90 is the interior angle of this triangle. Consider triangle CDE. Now this angle is an exterior angle to this triangle, okay, because it is the supplement of an interior angle, as we have discussed in the previous videos. Exterior angle is an angle which make a supplement, which is a supplement of the interior angles. Okay, they make an angle of 180 degrees with the interior. If this is the interior angles, the exterior angle of this interior angle is this one, and we know that the exterior angle is always greater than the non-adjacent interior angles. It means this angle CDB will be greater than angle E. Okay, in triangle ACD, angle CDB, okay, this one angle CDB, measurement of angle CDB will be greater than measurement of angle CED, because this is the exterior angle is always greater than non-adjacent interior angles. Okay, name this as 1. It means this angle is greater than this, but we know that this is 90 and this is also 90. It is given to us that CD is the perpendicular, CD is perpendicular to AB. So if this angle is 90, both these angles are 90 because this is a perpendicular to the side AB. Now if we know that CDB and CDE both are congruent because both are equal to 90 degrees, but angle CDB is congruent to angle CDE, okay, and both are congruent to 90 degrees. Let me write it here, angles. Now the reason for this will be, it is given that CD is perpendicular to AB. It was given to us. Now CDB is congruent to CDE. So if you look at the two equation, CDB is congruent to CDE and CDB is greater than CED. Okay, CDB and CDE both are congruent. This angle is greater than this angle, so this angle inside the triangle C, the angle CDE, this will also be greater than angle CED, because these two angles are equal, and if CDB is greater than CED, then CDE will be greater than CED, because both these angles were equal. These two angles are equal. Okay, if this angle is greater than this angle, then this angle, the angle inside the triangle, will also be greater than this angle, because both these angles have the same measurement. This is 90 and this is also 90. So if this angle is greater than E, then this angle will also be greater than this angle E, because both are 90. So from 1 and 2 we know that CDB is greater than CED and CDB is equal to CDE. So we can replacing CDE over here because both these angles are same. So CDB can be replaced by CDE because both are same. So from 1 and 2, what do we have? CDE will be greater than angle CED. Okay, this angle at the point D will be greater than the angle at the point E. Now this is from 1 and 2. Okay, so up to now we have obtained this. Name this as equation 3. I will erase it and write it this equation again because we are going to use it. So till now what we have obtained is that we have in triangle CED, we have come to the conclusion that this angle is greater than this one. Okay, so measurement of angle CDE is greater than measurement of angle CED. Okay, this one, this angle is greater than this. This was equation 3 that we have already proved. Now the side opposite to CDE, okay, CDE, the side opposite to CD and E is this side CE. This is the side which is opposite to this angle. Okay, so I am writing, we know that if this angle is greater than this, then the side opposite to the greater angle is always longer. So this will be greater than this side, and this will come to the result that we want to prove. Opposite to CDE we have the side CE. Okay, so it means measurement of CE will be greater than measurement of CED. CED, the side opposite to CED is CD. Okay, this is the side which is opposite to the smaller angle. So CE will be greater than CD. Now this is because side opposite to the greater angle is always longer. Okay, so if CE is greater than CD, okay, it means that CD must be less than CE, or CD is the shortest distance, because we have taken this point, this was any point on AB. If you repeat the same procedure, if you take E for example here, and again we are going to do the same, all these steps, we will get that CE is greater than CD. Similarly, if you take E at different points on AB, again we are going to get the same result each time. This angle will be greater than this, and this will also be greater than this. So the side opposite to CD will always be opposite to the smaller side. Therefore we will obtain whether we take E on this side of CD or on the other side, the same, according to the same reasoning, we can prove that this angle will always be this angle E. Okay, this angle E, because each time we will have a right triangle. Okay, if I take E here, we will have this right triangle. Again we will have the same argument. Similarly, if I move this point E on AB, each time I am going to get a right triangle, and this according to the same reasoning, following the same reasoning, I will always be able to prove that CE is always greater than CD. It means that CD is the shortest path from C to the line AB. Okay, CE is always greater than CD. This implies that, this actually proves the result. This implies that CD is the shortest distance from C to AB, because here we had taken E and E was any point on AB other than D. Okay, it is representing any point on AB, so it has proved the result for all the points. Whatever point we take on AB other than D, we will always get a right triangle, and we will always be able to discuss all these points that we have discussed for this E. So we will be able to prove that all the distances, all the at each time CE will be greater than CD, it means CD will be smaller than all the other distances, or CD is the shortest distance from C to AB. And this is how we are going to prove. We have proved that CD is the shortest distance, and this is what we needed to prove. CD is the shortest distance of C from AB. So let me summarize the result once again. We had a point, okay, we had a point C, okay, and we had to take the distance of this point C from AB. Right, again we had a line AB and a point C. This was the perpendicular distance of C, and we had taken any other point E, okay, and took this distance. This was a distance which was other than CD, because E was a point which was not at this point but at anywhere on AB. Now with the help of this, we know that this angle, this was an exterior angle, therefore we proved that this angle is greater than the angle at point E, and we know that both these angles are 90 and equal. If this angle is greater than E, then this 90 angle which is inside this triangle is always greater than E. And we know that the side which is opposite to the greater angle, okay, this was the greater angle and this was the smaller one. So the side opposite to the greater angle, which was this, is always greater than the side opposite to the smaller angle, which was CD. So each time CD will came out to be the smaller side, the shorter side. Therefore we have proved that CD is the shortest side. If you take any other length, it will always be greater than CD, it will never be less than CD. So this will prove our result that CD is the shortest distance of C from AB, and this completes the proof of the theorem.